So in this video we will discuss about the ionization constant of water, or you can say that as an ionic product of the water. What is ionization? First of all, ionization means the ions production. Ions production is called the ionization. So in this video we will do the ionization of the water. So we are having the H2O. We are having the two molecules of the H2O, as you guys all know. Okay, so we have taken here the 10 million molecules of the water. Okay, so we are like this is basically what this is the auto ionization. What does it mean? Auto ionization, which means that it will break by itself. It will break by itself and it will convert into the H3O plus OH. As you guys all know, this is acid which is giving hydrogen ion to the H2O. Acid which is giving hydrogen ion to the H2O, and the hydrogen is given to the H2O. So we are calling that as a acid, and this is the base. As you guys all know, we have considered the you can say that this one charges, or you can say this is a OH ion. We are considered always as a base. Okay, so this is what this is the ionized product. Ionized product we are having. So only one, you can say that only one molecule is getting ionized. From 10 million of water molecules, only one molecule is getting ionized. One H2O molecule is getting ionized. So that's why we are calling that as a weak electrolyte. We are calling water as a weak electrolyte. Weak electrolyte. It means the weak electrolyte. What does it mean? It means where the ionization of this reactant is very less. Okay, so if we are talking about the observation through the experiment, okay, through the experiment, so this was the H2O plus H2O. This was the unionized product, which was this, and this was unionized product, or you can say the reactant, and this is the, you can say, this is the ionized product. Ionized, this is ionized product, so we can write here ionized product. Okay, this is the larger one, and we are calling as a solvent, and this is the solute, which is the smaller, because as you guys all know, this is a larger molecule, large amount of molecule are there, like 10 million, and this is a like one molecule is like converted into the ionized product. So that's why we are calling it a smaller and a solute. And there you can say that there you can say this, we can say that this is like combining and making a solution. Okay, both ionized and the unionized, we are calling that as a solution. Okay, likewise, ionization can increase by heat, salt, but if it but it's that can increase by the, we can increase the, we can give the heat, and you can say that the salt, we can add the salt, so that can ionize more. But we are not giving anything. This is the pure ionization, so that's why we are calling that as a weak electrolyte. Okay, so with that I want to tell you guys one more. Today we are discussing the ionization constant of water. What is the constant of water? That is Kc. What is Kc? Kc is the equilibrium constant. What does it mean? It means that the ratio of ionic product, which is H3O and OH, as numerator, okay, and the reactant, which is H2O reactant, at denominator. Okay, so this Kc is basically not in that kind of a solution where the reactant is whole change into the product. So that will be the strong electrolyte. So the Kc is not in the strong electrolyte, this is always in the weak electrolyte, where the reactant do not, all the reactant do not convert into the product. So as you guys all know, in the water we have taken the 10 molecules, but only the one molecule is producing. The product is only one molecule, so that is weak electrolyte. So that's why the Kc is always in the weak electrolyte. Weak electrolyte. Okay. So we are having both ionic product and the reactant are in the container. Okay, so the Kc is in the weak electrolyte. So this Kc, we can say that this is the product, and this is the concentration of the product and concentration of the reactant. So as you guys all know, the product is less. As you guys all know, here you can see the product is less and the 10 million water molecules, the reactant is more. So that's why we have taken reactant as a denominator and product as a numerator, and this is the concentration sign, this one. Okay, after that we can write here that Kc, if we talk about the product, so product was H3O plus and OH. If we talk about the reactant, so we were having reactant that was H2O and H2O. Okay, it will move here, it will get multiply, it will be getting multiply here. So we can write here that Kc multiply by H2O, H2O, and that is equal to the hydronium ion plus hydroxide. This was the, you can say that the square will be occur, H2O square, because two molecules of H2O are there, and is equal to the H3O and OH. So we can write here that the constant of water, we can write that as a constant of water, this whole term as a constant of water, Kw is equal to the H3O and OH. We can also write as a hydrogen plus hydroxide. Okay, we are writing that as a constant of water, which is the reactant. We are writing reactant as a constant of water. We are writing reactant as a constant of water, and product we are having that is this. We can also write in the hydrogen and the OH signs, not plus, that is minus, sorry. Okay. So if you are finding out, let me give you the one example. We are having two container. We are having the 40% glucose solvent, and here we are having 60% glucose solvent, and we have taken you can say the, we have taken here the sorry, this is a 40% solute, and this is and we have taken solvent water. Okay, there we are having the 500 ml water, and here we are having the 500 ml water. Okay, so this will be the dilute solution because the solvent is very less, and this will be the concentrated solution, because they are, this is the, here we are having the more, here we are having the more solute of the glucose, and here we are having the 40 glucose, here we are having 60 glucose. So this will be the dilute solution, and this will be the concentrated solution. So this will be more electrolyte. Okay, this will be the less electrolyte. Likewise, if you are talking about the solution of water, if you are talking about which means the amount of solvent. So as you guys all know, we have said that we can also write H2O as a, this is the H2O, and this is changed into the product, which is H and the hydrogen, and we can write here that is convert into the H plus OH. Okay, this we have taken the, you can say 100 molecules were there, but the product is ionized only the one molecule. Okay, so we can write here that this was the amount we were having. We have to find the first of all we are finding the hydrogen concentration in the you can say the 10 you can say in the solution, and then we will find the you can say that OH ion concentration in the solution. First of all, we are finding the you can say that hydrogen concentration. So we can write here 1 upon, because one molecule is only become the, you can say the ionized. So 1 upon 10 million we can write here. We can write here this is a 10 million, because 10 million was the reactant and one hydrogen is basically the product here. So we can write here, we are finding the concentration, so we can write here that 10, you can see the molecules, 10 million. So we can write there as the minus 7. Okay, 1 2 3 4 5 6, we can write as the in, we have written as a exponential form. Okay, so if we talk about the hydrogen or OH ions, so we can write here 1 upon. Okay, so that we can also write as a 10 s power minus 7. So you can see that the hydrogen ion and OH ion in the solution, the concentration of these both are same. So that's why we are calling water as a neutral or the amphoteric. Neither it's the basic and neither it's the acidic. We are calling that as a neutral. Okay, we can write here that Kw is equal to the HOH. Okay, we can write, we are having the concentration of the H is 10 s power minus 7, and here we are having the concentration that is the 10 s power minus 7. If we add this, we can write it 10 s power minus 14, not 4, 14. Okay, so this is the ionization of the water. This is the ionization of the water at the 25 centigrade. Okay, so this is the ionization of the water, that is 10 s power 3.9 multiplied 10 s power 14 at 40 centigrade. So this is the ionization of the water, that is 10 s power minus 14 at the 25 centigrade. So we have finded out the constant of water. So this was about the ionization constant of water. Okay, in the next video we will discuss about the, we are having a new topic we are having, that is the about related to the hydrogen, the OH ion, that we will be discussing in the next video.